Okay, let's quickly review the lesson of the day. Today we started with this warm-up problem where we had a softball pitcher that throws a ball that can be, whose trajectory can be modeled according to this equation: h equals minus 16t squared plus 24t plus 1, where h is the height and t is time in seconds. So we can graph, or at least we can predict the trajectory of this ball when thrown would be something similar to this. If we have h as the height and t as the time, the c is equal 1, so the y-intercept, the h-intercept is 1, so we start from here, and then we expect the ball to be thrown and end up somewhat in the trajectory similar to the one I just drew. If you what we are looking for is how long it takes for the ball to touch the ground. So we are looking for h equals 0 for the x-intercept, or in this case the t-intercept. So we set the equation plus 24t plus 1 equals 0, and then we solve it. We can solve it in several different ways. We know two techniques: completing the square and factoring, but today we used something different. We used the quadratic equation, and the quadratic equation gives us the two t's, t1 and t2, so the two solutions as minus b plus or minus square root of b squared minus 4ac divided by 2a. Divided by 2a. Okay. We have, by substituting all the terms here, we get t1 and 2 equals minus b. B is 24, so we have minus 24 plus or minus square root of b squared, so 24 squared, minus 4, then multiplies minus 16, that's our a, times 1, that's our c. Let me extend here, and everything is divided by 2a. A is minus 16, so this would be a minus 32. If we go through the computations, we're going to find two values for t, the two solutions, t1 and t2, and I'm going to do this in my calculator, and what I find is that t1, one of the solution is minus 0. Let me write again. It's a negative. It's a negative 0.405. Well, actually 0.6, and the other one is 1.541 second. Okay, so the first one is an impossibility because, and in fact we know that we started from 1, so what we are actually finding is this value, but this value would be a negative time, so it would be something that, unless we have a time machine, we cannot have. So we can exclude this solution. The only real solution is 1.541 seconds. Now, this solution, as we discussed in class, seems pretty odd. The ball stays in the air only for 1.5 seconds. This seems to be a really bad throw. I would think that this model doesn't really reflect a real trajectory of a ball that's been thrown. But anyway, this is what the problem was. If I were to find this in real life, I would probably question if I did my math, and once I verify, I question the problem itself. But anyway, this is, as you can see here, your your scale is extremely high. So if we were to model this on your calculator, you would find that the parabola is extremely steep and comes down very quickly. So it's a model that doesn't really stand up. Okay, we want to now do some factoring using the reverse box method. This is a pretty fun way of factoring trinomials, and it works like this. We draw a square like the one that you see here, and we divide it in 4 different parts. The first box right here takes the first term. Actually, I'm going to remove this because this is the first term of our trinomial, goes in the first box. So we have 3x squared here, and then we place our c term minus 7 on this box. Next thing is we multiply a and c together. A multiplied by c, and in this case would be minus 21, and we are going to look for the factors of minus 21, then add up to minus 4. So if I were to draw a small table here, I can think about minus 1, for example, 21, minus 3, 7, and so on. If you look at these two factors here, they when multiplied are equals 21. However, they are not equals minus 4 when we sum them up. But if I change the sign of these two terms and I switch to 3 minus 7, I can see that when I sum these two terms up, I get a minus 4. So these are the terms I'm looking for. And at that point, I'm going to put those two terms with the x on these two boxes. Okay. Now it doesn't matter which, if you put minus 7x here, or and vice versa for the 3. It's this 3x is the same thing. So don't focus too much on where you put the two terms, how you split them. What's important is the next step. The next step is to go row by row and column by column and find the greatest common factors. In this case, my greatest common factor for this particular row is x, and the greatest common factor for this row, 3x minus 7, is 1. That's the only thing I can find. If I do now the column, the greatest common factor for this column would be 3x, and the greatest common factor for this column would be minus 7. Now I want you to notice that the signs that you use here are always the signs that you have inside the box that you're touching. So in this case, x is touching a positive term, so it's a positive x. 3x is touching a positive box, so it's a positive 3x, and so on. Here I'm touching a negative box, so the 7 takes a negative. You're basically done at this point. Once you've done this, you can look at these two binomials, and you could rewrite your equation as the original equation as x plus 1 then multiplies 3x minus 7 equals 0. If you want to find the solution, you set to 0 both binomials, so you do x plus 1 equals 0 and 3x minus 7 equals 0, and you will find that x, it's equal, the solution x equals minus 1 and x equals 7 divided by 3, 7/3. And this is how you use your reverse box method